Hello and welcome to the Data Structure and Algorithms online tutorial video. In the last video we saw what are the types of trees, and in this video we will learn about binary tree. In a binary tree, each node can have maximum 2 children. Binary name itself suggests that 2, therefore each node can have either 0, 1 or 2 children. We will see some of the general properties of tree. As we discussed, binary tree have at most 2 children. You can see in the tree here, node 1 has 2 children, node 2, node 3. And node 2 and 3 have 2 children each. Let's add some more nodes to understand it better. Now I will add one more node as a one child. As we discussed, in a binary tree, a node can have 0, 1 or 2 children. Node 7 is having only one child node. We call 2 children of the node as the right and left child nodes. We saw in our previous video that the topmost node is the root node and it has 2 child nodes. 2 is the left child of the root node and the 3 is the right child of the root node. Node 1, 2, 3 and 5 have both right and left child node. But node 7 has got only left child and right child is not there. In programming language, we can say that value for the right child is null. All the nodes that does not have right and left child nodes are leaf nodes. So here 4, 6, 8, 9 and 10 are leaf nodes. For all these nodes, both left and right child node values are null. Now we will see logical representation of the tree. This is the logical representation of the tree we saw till now. Node 1 contains 2 pointers, that is left and right pointer, pointing to the left and right node respectively. The node 2 contains both nodes, left and right node. Therefore, it has 2 pointers. The node 3, 5 and 6 are leaf nodes. So, all these nodes contain null pointer on both left and right part. Now, we will see types of binary trees. There are 4 types of binary tree: full or proper or strict binary tree, complete binary tree, perfect binary tree, degenerate binary tree and balanced binary tree. Full binary tree is also known as a strict binary tree. The tree can only be called as a full binary tree if each node contains either 0 or 2 children. The full binary tree can also be defined as a tree in which node must contain 2 children except the leaf nodes. We see that each node is either containing 0 or 2 children. Therefore, it is a full binary tree. In complete binary tree, all the nodes are completely filled except the last level. In a complete binary tree, the nodes should be added from the left. As you can see, the tree shown here is a complete binary tree because all the nodes are completely filled and all the nodes in the last level are added at the left first. A tree is a perfect binary tree if all the internal nodes have 2 children and all the leaf nodes are at the same level, and the tree shown here is the example of the perfect binary tree. The degenerate binary tree is a tree in which all internal nodes have only one child. Tree shown here is a degenerate binary tree because all the nodes have only one child. It is also known as the right skewed tree as all the nodes have right child only. This tree is also a degenerate binary tree because all the nodes have only one child. It is also known as the left skewed tree as all the nodes have left child only. In balanced binary tree, both left and right trees differ by at most 1. For example, AVL and red-black trees are the balanced binary tree. Tree shown here is a balanced binary tree because the difference between the left subtree and right subtree is 0. And this tree is not balanced binary tree because the difference between the left subtree and right subtree is greater than 1. A binary tree is implemented with the help of pointers. The first node in the tree is represented by the root pointer. Each node in the tree consists of 3 parts, that is data, left pointer and right pointer. To create a binary tree, we first need to create a node. We will create the node of the user defined as shown here. Struct node int data struct node asterisk left asterisk right. Data is the value. Left pointer contains the address of the left node and right pointer contains the address of the right node. The process of visiting the node is known as the tree traversal. There are 3 types of traversal used to visit a node: in-order traversal, pre-order traversal and post-order traversal. In the next video, we will discuss about binary search tree. Please like the video, subscribe to our channel and please hit on bell icon to get notified whenever we post new videos. Install DSA application from the Google Play Store or from the link given in the description below. Please let us know if you have any queries in the comment section below, and thank you for watching.